says assume that it's a linear function. That means it's, y equals mx plus b kind of thing when they say linear. All these are going to be linear because this whole section is linear functions. Find the cost function and use it to evaluate the cost of producing 1,500 and 1,501 omelets. Then find the marginal cost of the 1,501st omelet. And any omelet. Okay. How do we do all that? And then there's the multiple choice answers. So how are we going to do that? That's an average. It's big, kind of bad down here, huh? I wonder why it does that. Yeah, so what we're going to basically do is use the y equals mx plus b thing, and we're going to plug in two different sets of points they're giving me. They're telling me 100 omelets, that's our x, and instead of y, why don't we put, like, cost? Because that's what they said the function is, a cost function. That's like our y. C is playing the role of y. So for 100 omelets, the cost is $118.64. For 1,000 omelets, the cost is $1,050.14. So they're giving me two pieces of information like that. How do you go about finding the equation when they do that? Well, there's actually lots of different ways to do it. It doesn't really matter how you do it. I'll show one method that's probably one of the easiest. First, find m, the slope. Remember how to find the slope? Slope, you remember from your algebra days, slope is y2 minus y1 over x2 minus x1. Do you remember that kind of formula? Rise over run, y's over x's from your algebra days for finding slopes. Okay, so maybe I'll have to phone in. It's kind of bad. I'll call the tech guys maybe tomorrow if I remember. I'll write myself a note. Call the tech guys. Okay, so let's plug in. Now remember, the y's are c's. So really this is c2 minus c1. Okay, so we'll call this x1 c1, x2 c2. Makes sense what I'm doing? And so C2 minus C1, so 1,050.14 minus C1. Put these in red maybe, which is 118.64. Over X2, which is 1,000, minus X1, which is 100. Good so far? So rise over run, y's over x. That's how we find slope from algebra. Trying to find our m. Remember, my whole point is I'm trying to find the equation mx plus b. That's my goal. They said find the linear equation. Find the cost function. So first I'm finding the m. So let's use our calculator then on that. M equals, so if you subtract those on your calculator, I got my calculator here. It's going to be 1050.14 minus 118.64, 931.5 over 900, huh? Yeah. So you could divide that, but it would be something ugly, I think. Oh, no, I guess that's not bad. Okay, I'll go ahead and do it. So if you divide those, you get 1.035? Yeah. If you divide them and they come out like super ugly, like a decimal that goes on forever, then I would just leave it as a fraction. It'd be easier that way. But if it's clean, then yeah, okay. We'll just divide it and use that number. Just do whatever's easier. Okay, so that's step one. We've got m. We've got this piece of the puzzle. Now, we also need to finish it up. How do we finish it up? Well, here's my suggestion. I have maybe a way that's a little different than what's normally done. I think it's a little easier. Use, again, m, but this time when you write the m, we're going to do like the y2 minus y1 over x2 minus x1, but I'm going to change it up. Instead of y2 and x2, I'm just going to make it, and those are supposed to be c's on the top, aren't they? So I'm going to make it plain c and plain x in the front. In fact, let me do it a different color so it's helpful. It's plain C, plain X in the front. Everybody see what I'm doing? I'm using the same basic formula that we used up here. Same basic formula, right? C2 minus C1 over X2 minus X1. But the same thing, except I'm just doing a plain C and a plain X in the front, which means I'm not going to plug into those two. They're just going to stay plain C and plain X. And now I know the M. M's this. I'll put that in right here. 1.035. And the plain C and the plain X will just stay as they are. And then what goes in the back? Well, C1, X1. Here's C1. We're going to use it again. 118.64 over X1, which is 100. Everybody see what I did there? So it's like I'm using the slope formula twice. I am using the slope formula twice. The second time, a little different way with plain C and X. Why? Because then I'm going to use this to finish up and have my equation. Let me show you. I do this to avoid fraction work. This particular method avoids a little bit of fraction stuff. So what I'm going to do now, everybody good so far? I'm using the slope formula twice. I'm going to put this over 1 to make it look like a fraction. And then I'm going to, remember when you have two equal fractions, you can diagonal cross multiply. Remember that from algebra? So in other words, this will multiply that. And on the other side, this will multiply that. Diagonal. Cross multiply when you have two equal fractions. So what do we have then? Bring it up here. 1.035 times x minus 100 equals, and then the other side, 1 times c minus 118.64. Kind of running out of room there. Write that again. Is that good so far? Everybody see what's happening there? So I went diagonal, cross multiply. I'm trying to get this equation. I'm almost there. So now distribute. So 1.035x minus 100 times a number moves the decimal in two places, doesn't it? 103.5. This side, distribute, that doesn't do anything. 1 times c is just c. 1 times 118.64 is just 118.64. We good so far? Last step, what are we trying to do? Get c alone. This formula that we want has c alone, doesn't it? So last step, get c alone, just add the 118.64. Y'all with me? Add the 118.64. So if I do that now, if I add 118.64, add 118.64 to both sides, that's gone. C alone is 1.035x plus whatever that is. Is it 15.14, I think? There we go. We found the equation for the cost of however many omelets. See how that works now? You could plug in X number of omelets and just figure out the cost from those original two pieces of information. So let me recap that again. I know it's been a while since you've done algebra. This is a little messy. So what did I do to find, and when do you do this? Like, how do you know when you're supposed to do this whole thing? When they want you to find a linear equation. A lot of the battle in a math class, you know, is like recognition. Like, how are you supposed to know to do what when? There's so many different things we do. So I'm trying to help you with that. When they say find the linear equation, that's when you do this double M process. At least that's one way. There's other ways. If you have some other way you're good at, feel free to do that. I never care. But this I found is about the easiest way for students over the years. So I use the slope formula twice. I'm trying to find y equals mx plus b, or c, cost, equals mx plus b. And I'm finding it using the slope, rise over run. Difference of y's over difference of x's, difference of c's. C is playing the role of y over difference of x's. So I subtracted the two c values, right? I have x and c, x1 and c1, x2 and c2. Difference of c, c2 minus c1 over x2 minus x1. Got my slope, and then I started with the slope formula a second time. This time I had a plain c and x in the front, because I'm not going to plug into them, instead of c2 and x2. That's the only difference. Put these guys in the back, cross multiply, got c alone by adding the 11864, and there's the formula. So that formula can be used now. They can tell me, all right, we're going to make 57 omelets. What's it going to cost us? And I can just plug 57 in for x, times 1.035, add 1514, hit equals, and I'll know the cost of making 57 omelets. So that's what that formula is for now. Remember what the different parts of a linear formula mean? What does the 1514 mean?
Initial startup.
Initial, that's the startup. And then the 1.035 is the per each item, also called marginal. Marginal means, remember, margin is small, it's for 1. So that means it costs $15.14 just to set up the omelet making thing. I don't know what that is. That a spatula and a bowl? I don't know what the $15.14 is. But the initial cost to get going on making omelets, before you've even made one omelet, the setup cost is $15.14, maybe for a spatula and a bowl. And then $1.35 and a half on 1.035. That's $1. No, it's not $1.35. It's $1.03 and a half. So just over $1.03 for each omelet you make after that is what it costs. So that's the marginal. This is always the marginal here, because marginal means for just one omelet aside from setup cost. All right, so what's their... Oh, and they had it rounded, huh? So it is A. They just rounded it, didn't they? Oh, no. Oh, no, I'm not looking carefully. It is it C? Oh, yeah, C. It is C, yep. Well, 1540. Yeah, there it is. So it's answer C. Is the right one. And then the next question they're going to ask is they're going to say, find the cost of 1,500 omelets. Let's go to a fresh screen and we'll do that. So our formula was C, 1.035x plus 1,540. So 1,500 omelets, that means just plug in 1,500, doesn't it? And whatever your calculator tells you, times 1,500 plus 1,514. All right, 1, 5, 6, 7, 64. So there's the cost of making 1,500 omelets. And then we could do the same thing for 1,501 omelets, and we already answered the marginal. The marginal is just the 1.035. So I'm going to leave that one behind. Are we good with that? So this class, we're just learning the math that goes with business. And so there's typical business kind of math setup. Any questions? Is that all good? All right. Okay. So they want us to assume that the following has a linear cost function. So again, it's linear. Notice there's some y equals mx plus b kind of thing. Or c, we're using c in the place of y. Cost equals mx plus b. Okay. Find the cost function, the revenue function, and the profit function. Oh, okay. So it says fixed cost, marginal cost, and then item sales. We'll get to that. So what does it mean when it says fixed? Can you guys tell me what the... we know the M is what? Yeah, M's the marginal. M's the marginal, the 10. And then what's the B? It's the fixed, right? It's the setup cost, or you can also call it fixed cost, what you have to do just to get the operation rolling. So that's the 500. So there's the cost. Now, what's the 45? We'll get to that in a minute. There's the cost function, first off. It's just got a marginal part, how much for just one per item, and then the fixed cost. So the per item cost times X number of items, plus the 500 setup cost or fixed cost. There's the cost function. Next, it wants me to come up with a revenue function. Revenue means the money you get when you sell this product, as you know. So revenue. So what's the revenue function? What's the money we're going to get? Well, it says right here that these things sell for $45 an item. Each item is selling for $45. So what's the is the revenue function then just 45? We've got to have the X, huh? Because it's however many. X is the number of items, right? X is always the number of items, omelets or whatever it is we're selling. So it's $45 times the number of items, $45 each item. So there's the revenue function. Revenue never has a fixed part. People don't buy things that way. That isn't right. They just pay per item. So that's all we just have the per on a revenue function. Next, that's the cost, revenue, third part. They want us to come up with a profit function. How are we going to come up with a profit function? How do you know how much profit a company makes? Yeah, it's just money coming in minus money going out, right? Just as simple as that. Whatever they take in minus what they had to put out to produce that product. Revenue, profit is always revenue minus cost. So we just take the revenue function, 45x, minus the cost function. Now I got to put the cost function in parentheses because that way we'll subtract both parts of it. Right? It would be a mistake to just do it like that without the parentheses because that's not really subtracting the whole cost function. That's only minusing the 10x part. So you're supposed to put parentheses, or you could just make them both negative right away because that's what will end up happening. Minus 10x minus. If you want to just make them both negative right away, that's okay also. So there's the profit function. And let's gather like terms. 45x minus 10x, 35x minus 500. There's the profit function. So that company can figure out how much profit they're going to make based on how many items they sell. Plug in, 100 items, 35 times 100 minus 500, because that's the fixed cost just to get the operation going. They'll know how much profit they're going to make for selling that many items. That good? See how I came up with all those parts? So once again, cost has a per item and a fixed. Revenue is just per item. Profit is revenue minus cost. You'll get a 3x5 card for each exam. Did I mention that? So every exam, you'll get a 3x5 card. You can write anything you want on both sides of a 3x5 card. So anything you have in trouble memorizing, you can just write it on that card. All right. Let's keep going. If you don't have... Let's take a look. So... Okay, what do you remember from your algebra days about this kind of thing? I'm going to rewrite it a little bigger here. Yeah, they want me to find the intersection. How do we do it? What do we do? Yeah, there's actually a couple ways to go. You can do the get rid of one of the letters way, or you can do the plug one function into the other way. It's called elimination or substitution. I never care. Would it be helpful if I show both, or is that more confusing? Maybe I'll show the substitution. I assume that's probably one of the ways you're thinking right away. So here I'll show the substitution method. And that means, see how the second equation already has y alone? This one's real convenient for substitution. It's already got y alone. So that means y equals 5 minus 3x. So that means wherever I see y, I can replace the y with 5 minus 3x because y is equal to 5 minus 3x. It's the same as 5 minus 3x. So that means right there. You always plug one equation into the other in the substitution method. So you get one letter alone. Conveniently, y already is alone. That's why I would say this is so nice. It's kind of like ready to go. And then plug into the opposite equation. You always plug into the opposite equation. We never plug into the very same equation. Always plug into the opposite. So what do we get then? When we do that, we get 5x minus, and then 5 minus 3x equals 11. Everybody see how this equation comes down here? But in the place of y, I put 5 minus 3x. And again, I put parentheses. Whenever you plug in, you put parentheses around what you're plugging in so that you do the operations to everything there, not just the front part. Does that make sense? When I plug the 5 minus 3x in here, I have to subtract the whole 5 minus 3x. So that's why the parentheses indicate that. Right? This minus will distribute to both of them. So you'll end up subtracting them both. It'll actually change the back one to plus, won't it? 5x minus 5 plus 3x. 5x and 3x. Yeah, these guys will make 8x. Minus 5 is 11. Yeah. Bring it up here. So 8x minus 5 is 11. Yeah. So we've got to add the 5 now. As these are gone. 8x is 16. Last step, divide by 8. X is 2. Oh, and they don't just want x. We got to get y also. I thought we were done. So we're 90% done. So x is 2. Now they want intersection point. See, they say type ordered pair, so they want x and y. They want the pair. Yeah, just plug in x, and really anywhere you want. It doesn't matter where. You can plug in literally anywhere you want, and you'll get it. Since I want to get y now, the easiest place to plug in would be right here where y is already alone. You could plug into the top equation. It would work. You just have more steps to do because you'd have to get y alone. Either one's fine. I'm going to do the easy one. Y equals 5 minus 3x. Plug in the 2 there. Five minus 6, negative 1. So y is negative 1. So what's the answer to the question then? It is 2, negative 1. Ordered pair means parentheses, x comma y. Parentheses like that. Whenever they say ordered pair, they mean two numbers with a comma and the parentheses. X comma y. That's the intersection. But that means if I was to graph these, if I was to do a graph, these are both like lines, they would intersect at the point over 2 down 1, which is not at all what my graph looks like, but I just made it up. You get the idea. Behind the scenes, there's a couple lines, and they're intersecting at the point over 2 down 1. Good, but we don't have to show that. We don't have to graph or anything. I'm just letting you know that's what's happening. Good? Questions on that? Remember that from Al? Yeah, they both have y alone, so it's real nice for that. So y equals 9x minus 4, and y equals 2x plus 9. Yeah, so then I just say, just plug it in right there. Or vice versa. You can take the top, plug in the bottom, or bottom into the top. Doesn't matter. Plug one of them into the other one. And what are you going to get? You're going to get 2x plus 9 equal to 9x minus 4. See what happened there? Because, the bottom one's equal to y, so plug it in for y in the top one. So then, now how do you solve an equation where you have x's on opposite sides? Here's the equal sign. I have x's on opposite sides of the equal sign. What do you do in that case? Yeah, get rid of one of them, right? You don't want 2 x's. You got to get rid of one of them. So subtract 2x. Boom, that's gone. So 9 equals 7x minus 4. Like that. And then we finish it from there. So we add 4. So we'll get 13 is 7x. Last step, divide by 7. Boom, there it is. Oh, they want the y as well, don't they? So I got to get y. So there's x. Yeah, that's too bad. I guess it won't be the worst thing in the world. I'm being dramatic. So x is 13.7. So now we got to go get y. I'm going to have to plug in with a fraction. So let's do that. So you can grab either equation. Doesn't matter. They're the same. They're y's alone in both cases. I'll just grab the first one. So 9x minus 4 is the equation. And then I plug in x. X is right here, 13/7. Take that x. I just plugged it in there. So now you gotta do something about that. Do you like fractions? No, they're kind of a pain, aren't they? And by the way, they do require fraction of the answer. The blue line tells you the format of the answer. They want a fraction answer. They don't want a decimal. See the blue line? See what I'm talking about on that? Type an integer or a fraction. In other words, it doesn't say decimal anywhere, does it? They're not going to accept a decimal answer. They want a fraction. If you're ever unsure, by the way, here's how you would know. You thought I was trying to get out of finishing these fractions, huh? All right. Let's do that. So we got to finish this up. What do you do when a whole number is interacting with a fraction? Yeah, put it over 1. Make it look like a fraction, huh? Make it 9 over 1. So let's do that. And then you just multiply the top times top. I'm kind of running out of room here. Let me go over here on that. So I'm going to go 9 times 13. What is it? 90 to 117 over 7 minus 4.
Change 4 into a 7.
Yeah. Good so far? See what happened there. I just did 9 times 13. 9 times 13 made the 117, and 1 times 7 made the 7 on the bottom. Just top times top, bottom times bottom. So this is what y equals. Let me bring it up. Let me change it up a little bit here. So this is y equals. Okay, yeah, now to finish combining those two fractions or subtracting, you got to, again, put it over 1, make it look like a fraction, and multiply top and bottom by 7 for common denominator. Remember all that messy business? Get this out of the way. And so then we've got y equals 117 over 7 minus, what's that, 28/7. See, 28/7, that's a fancy 4, isn't it? 28 divided by 7. That's just a fancy 4. Right? It was a 4, it is a 4, it just looks different now. And now we can subtract them. What's that?
89.
No, it is, thank you. 89/7. That's our y. So our x, I erased it, but it was 13/7. And our y is 89/7. X, y, we're done. They want parentheses, comma, ordered pair. Whenever they say ordered pair, they mean parentheses, comma, 2 numbers. So there we go. A little messier than I thought it was. I was just going to skip that one. So that would be good that, as you look at the YouTubes ahead of time, just let me know. Go, hey, Mr. Aaron, can you go over number 12? 12 turned out to be ugly. Because I forget which ones get messy and which ones don't. That way I can be more helpful in our time together. Questions on that? We good? Okay, number 13. So their monthly revenue dollars. So it's giving me a revenue function. It's giving me revenue. That's the money that comes in. And cost, that's the money goes out. We know profit's the difference between those, right? Revenue minus cost. Anyway, find the break-even point. What does break-even mean? If the company say, hey, are you at least breaking even? Is the company breaking even? What does that mean? Yeah, just zero, huh? The money coming in exactly equals money going out. Breaking even. Same in, same out. Zero profit. At least they're not losing money, right? Breaking even. So whenever they ask you break even, you set cost equal to revenue and solve. Because that's what it means to break even. The costs exactly equal the money coming in. So that means that I want to have 60x plus 2,400 cost equal to revenue, which is 80x. Bless you. Good so far. Now we just solve for x. So I just set the cost function equal to the revenue function. Because that's what it means to break even. Now we just solve for x. So what's my first step to solve for x there? Yeah, when you have x on opposite sides, of the equals, you don't want two of them. You just get rid of the lower one. Or either one. You can get rid of the bigger one. It doesn't really matter. I'm just going to get rid of the lower one, the 60x. Whatever you do to one side, I got to do to the other. Gonzo. So then we have 2,400 20x. Like that. And then the next step, last step, divide by 20. And that is, what is that? 120? Yeah, x is 120. You can use calculators for homework tests, everything. So x is 120. So that's the break-even point, 120. What does that mean? Doesn't that mean, remember what x always is? X is the items. So 120 items, and the company will break even. Usually, that's an important thing that businesses figure out, is how many do we need to sell to at least break even? We don't want to lose money in this venture. We're hoping to make a lot of money, but are we sure that we can at least sell 120? And technically, it's 1,000 policies, they said, right? X is 1,000 policies. So this insurance company is thinking, look, as long as we can sell at least 120,000 policies, we'll break even. You know, building the whole building for an insurance company and buying all the computers and everything they need to get going. They're thinking as long as we can at least do 120,000 policies, we will break even. We won't lose money. Anything above that will be profit. Anything below that will lose money. That's what that's telling us. So that's part A. Part B, graph the revenue and cost equations on the same axis, this axis. So I'll show you how to do the clicker thing. Let's first do it by hand, and then I'll show you on the actual MathXL clicker thing. So to graph both these, so one at a time, I don't know which one they want first. Let's go see. Let's go back, and we'll flash back and forth. All right, so here it is. Yeah, did you notice the break-even point, 120? At 120, what happens? They intersect because revenue and cost are equal. This is the revenue graph here. And the other one's the cost graph. And they meet each other. And then after that point, if you make more than 100, you make 140 or whatever comes next. They're going by 20s, aren't they? Yeah. 140 is here, I guess, and on. Then, if you're in that point, you're up here, your revenue will be above your cost, won't it? You'll be making profit. All of this, this shading difference between these two is profit. That's why the company wants to sell more and more and more. Because as they go more and more and more, revenue stays here, and the other line, cost stays there, and revenue gets farther and further above it. And that's profit. The difference between revenue and cost is profit. So that's why they want to sell more than 120. 120 is break even. Anything less than 120, revenue is under cost. They're costing more than they're making. Right? That's what that graph is showing. That makes sense. So again, let me write out real quick the steps for how, because I didn't record that on YouTube. So again, the steps real quick. So the revenue function was, what is it? 80x. How are we doing on time? Okay, 80x. So what I did is I made a table for that, XY table. Y is really the same thing as R. And this one, and I did 0, 0. And then I did, 100? Yeah, plugged in 100, and revenue was 80, times 100. Which came out 8,000. Put that back here and graphed it. And then for the cost function, which was 60x plus 2,400. Same kind of thing. I did an XY table. And Y in this case is really C. I did 0, 0. Oh, not 0, 0. It's 0. When I plugged in 0, cost was 60 times 0 plus 2,400. Cost would be 2,400. And then I did 100. I just plugged in 100. When you plug in 100, you get 60 times 100 plus 2,400. And cost came out 8,400. So put those dots on the graph. And we got our graph here. Now what are they asking? They're saying from the graph, estimate the revenue and cost when x is 60. Use the zoom feature of the graph as necessary. So they're saying, hey, if x is 60, if you're here, this is 60, isn't it? Right here? So this must be 60, halfway between 40 and 80. If you only make 60 items, or I guess it's 60,000 policies, what if the insurance company only sells 60,000 policies? What's going to be their revenue and what's going to be their cost? Well, if you go straight up, boom, the revenue is 4,800, isn't it? And their cost is right here. Is that the middle? I guess that's the middle of those two. So I'm not sure what that is. Those numbers are hard to tell. That's going to be the cost. What would be easier, honestly, is just taking that 60 and plugging it into the cost function rather than trying to mess with that graph. You know, the cost is going to be 60x plus 2,400. So plug in 60 for x, and you'll get, what is that, 3,600 plus 2,400. Cost equals, that's 6,000 even, huh? So it'll cost the company $6,000. They'll make a revenue of $4,800. They'll lose money. It's costing them more than they do revenue. So we can answer those questions. that good? Everybody okay with how I found that? Let's go back and answer those. It was cost was 6,000, revenue was 48. Everybody okay with that one? Was there any questions on that last one? Is that good? All right, so there's the stuff we worked out. Yeah, so in this one, they're giving me revenue, which is 0.25x. And what kind of strangely, they're giving me profit. It's not normally they give me revenue and cost, right? This time they're giving me revenue and profit, and they want me to find cost. So this is 0.82x minus 0.9. So revenue and profit, and they're saying, hey, what's cost? So remember the relationship? Profit equals revenue minus cost. That's how they're connected, right? The three equations. How much money the company makes in profit is what's coming in, revenue, minus what's going out. So if that's the case, can I solve that little equation for C? Or yeah, let's just plug in. How about that? Just take this and plug it in for profit right there. So 0.082x minus 0.9 equals revenue, which is 0.25x minus cost. That good? See what I did there? So we keep using, good one to put in a 3x5 card. Is profit is revenue minus cost. Plugged in profit, plugged in revenue. This is profit. This is revenue. Now, how do we solve cost? Cost, we want to get cost alone. So what should we do? Let's subtract 0.025x. Subtract 0.025x. Whoops. Look at that. I said one thing and wrote another. Don't make the mistake I just did. It's not 0.025x, is it? It's 0.25x. Easy to mess up. There we go. All right, subtract that from both sides. It's gone there. Bring it over here. So use your calculator. 8 cents, or 8 and 2/10 of cent. No, 8.2 minus 25 cents. So that's negative 0.168. X minus 0.9 is negative C. Right? Because that negative sign remains in front of C. How do we get rid of that negative sign in front of the C? Yeah, multiply both sides by -1 or divide by -1. It'll work either way. Doesn't matter. So I'll just say, hey, multiply by -1, -1, -1. So that'll be positive C is positive 0.168x plus positive 0.9. There we go. There's the cost function. Last thing is they're going to ask a second question. What is the break-even point? How do we find break-even point? What am I going to set? What's that? Profit zero, huh? Profit zero or revenue equals cost. Same thing. Either one will give you the same answer. You can either say profit, and that's the easy way. I would just grab that profit equation, set it equal to 0 and solve, because when profit is 0, that's when you're breaking even, huh? Or you could just set, now that we have the cost function, you could say, I'm going to set cost equal to revenue. That'll give you the exact same answer. It's the same thing. Saying cost equals revenue, or saying profit is 0, because when these guys are equal, profit is 0. Right? Same spot, either one. Okay, I'm going to move on and see if there's some other hard ones. We've already done that. Or here, maybe I can do. Say, this is where I get in trouble. I always feel funny leaving one unsolved, but then I don't get tired. So real quick. So break even, profit equals 0. So you just grab that profit function right here, 0.082x minus 0.9 equal to 0, and then you solve for x. I'm going to skip some steps. I'm just going to jump that guy to the other side. What happens when you jump something to the other side? Just change the sign. It was a little quicker. Instead of adding, same thing as adding, 0.9 to both sides. And then just divide by 0.082. And there we go, whatever your calculator tells you. And I'm getting 10.9756. You guys get that? Did I do that right? I'm having trouble seeing with these low lighting over here, and I'm an old person. My eyes are so. But I think I got it right. Yeah, 10.97. So what does it want me to round, I guess? 11? Let's see. Let's go to this. So rounding, when they say round to the nearest thousand has 3 zeros. So that means round to the third place. And then you circle that place, you look one to the right. If the one to the right is 5 or more, you go up. So 976, right? Rounding to the thousandth. Just circle the thousandth place. That's 3 zeros. Circle that place, look one to the right of it, 5 or more, round that up. So that's what they want for the break-even point. Okay, so, yeah, supply and demand, where they equal out is called equilibrium point. And we're right there. And so what's the coordinates? That looks like it's over... Are each of those jumps 33? I'm looking at the bottom here. It looks like 0, blank, 66. So it must be 33 per jump. Does that make sense? This must be 33, and then another 33, 66. This must be 99. I added 33. So it's weird. The jumps are going by 33. See how I came up with that? So that must be over 99. And how high up is this? Oh, they're going by 33 on the other axis too. Yeah. Right? This is going by 33s. 33, 66, 99. So this is whatever 132 plus 33 is. 165. This must be 165. So that equilibrium point is 99, 165. Units, which one is units? Oh, quantity, price. So 99 units, price, 165. So those are the two questions. Good on that, just by looking at the graph. There's a lot of hard questions. It's a pretty tough section. The next one's a little easier, I think. Yeah, definitely. 5.1 is definitely easier. Okay, there's a lot of different things in this section. So this is Q is demand, notice. So that means you got to really pay attention to which one's which. This one here, because they kind of look the same, this is a demand line. So one of these, it's going to be the demand, which is actually this one. This is demand. We'll get to that in a minute. And this one is, let me just change, it's a supply. This other one's supply because it says Q is supply. Okay, so they give me supply and demand. And they, what was question A? Okay, so again, this is demand. This is supply. So, what do I do? Find the price for a demand of 65,000 exhaust fans. Demand 65,000 exhaust fans. We're going up to we're talking about demand one. We're talking about this one. Well, I should use the same color. We're talking about that one. And they're saying P is the price, Q is the demand. The demand is 65,000. So they're saying take 65,000 Q, plug it in right there. So P is 480 minus 2/5 times 65,000. Does that make sense what I'm doing there? I found which equation, well, they're talking about demand, go to that one, and they're saying find the price, find P for a demand, 65,000. So just use your calculator on that, and I guess you'll get this answer they have right there. Next part, find the demand for the price of 74. Now they're giving me the price, the P, of 74, and they want me to solve for Q. Solve that little equation for Q. I'm still using this guy. We're still talking about the demand equation, but they're going vice versa. Now they're giving me the price, the P, and they're asking for the Q. That's a harder game to play that way. I got to solve for Q. How do you solve that equation for Q? There's a couple ways. I'd get rid of that fraction first off. I'm going to multiply through by 5. Cancels here. What's this? 5 times 74, 370. This is some number too big for me to do. 5 times 480 is 2,400. Minus 2Q. Everybody see that? Got rid of that. And then subtract 2,400. Boom, and that's 370 minus 2400 is minus 2030 equals minus 2q. Last step, divide by minus 2. Q equals, what's 1015, huh? Which is the answer. So they do the same thing on C and D, except they're asking you about the other equation, the supply equation for C and D, and then we're out of time. The last ones are just, do the graphs. So you're going to have to graph both those, kind of like we graphed that other stuff. Woo! That's a meaty section. There was a lot to that. All right, so the homework due Tuesday is 3.3. And make sure if you haven't grabbed a graphing calculator yet, go right over to the library, get a free one so you don't have to pay $100. Grab a graphing calculator, check it out for free at the library. Math Excel homework, so on the website, that'll be due, purchase Math Excel on Tuesday, 3.3, and clickers for next Thursday at the bookstore. So those are at the bookstore. Those are at the bookstore, but the Math Excel is online.
How much are the clickers again?
Clickers are $50 for that tiny little clicker.
So,
have a good weekend, guys.
On the first day, I just missed the beginning of 3.3.
That's right, and it's on YouTube.
On YouTube.
Yeah, if you want to go back to YouTube.
Yeah, I wrote it all down.